So this is part 2 of the lecture that I uploaded already. So you're going to get the second half of the lecture about the density. So we left off with regular density, how to find density of a regular object. Now we started with irregular densities. So it's very much similar. The only difference is the volume. So I'm still going to take this little magnet and I'm going to put it on a triple beam balance and find the mass of it. So I'm not going to do that, but by now you should know how to do that. And let's say I find the mass to be like 40.05 grams. Now remember, it has to be 2 places past the decimal. Now this is density of an irregular, I can't spell, of an irregular object. So we're looking at densities of irregular objects. These are objects that aren't like cubes. They're not perfectly squared or anything that we can do with. So what do we do with it? Well, we have the mass. Now we've got to find the volume. Well, how the heck do we find volume? First thing we need to do is find VI. And VI is initial volume. Initial volume. And you will have to know this terminology. So VI is initial volume. So then what we're going to do to find initial volume, we're going to take our graduated cylinder here and we're going to put water into it. Doesn't matter how much, you're just going to put water. You're going to put enough water so that when I go and put this in, it'll be fully submerged and it'll sink to the bottom. So it needs to be fully submerged in the water so that the water rises. It can't be just barely. So, you know, I usually, on the bigger cylinders, anything, you can go halfway or even a quarter of the way. That's usually potentially a good place to go. So then I'm going to read it just like I normally would. Set it on a flat surface. Get low at eye level so that you can see that. This happens to be at like 28.9. Okay, so that's my initial volume, is 28.9. Now, because we're using a graduated cylinder, it's going to be 28.9 milliliters. Okay, so now that's our initial volume. Now we need to find our final volume, which is VF, which is final volume. Again, you're going to need to know all this. So VF is final volume. And how you do that, now my graduated cylinder is not big enough. I didn't get a big enough graduated cylinder to do this, but I'll show you. First of all, this magnet is really heavy and it will break the glass. So anytime we're dealing with metals or anything heavy, you do not just want to drop it in. It will shatter the glass and then you have broken glass. Then you have to clean it up and you don't want that mess. And it's dangerous. So whenever you have something, what you're going to do is tip the graduated cylinder and you're going to slide it in or let it roll into it so it goes up. We do this so that it doesn't break this and then the volume will move and this is fully submerged. Now, like I said, I didn't get a big enough graduated cylinder to slide it in, so I'm sorry. So once it's in, you'll see the water shift up. That is your final volume. Don't forget, you're reading the bottom of the meniscus. So let's say it's lit in, the final volume was at like 35.7. That's what we're going to go with. So now what we want to do is find the volume of that magnet. Well, how do we find the volume? Do you remember how to find the volume? Take the time and see if you can remember how to do it. I'll give you a few seconds to try to figure it out. You got this. You can do it. Just try. You got this. All right, I'll give you a trick. So I'll give you the formula and then you can try. So you're going to take VF minus VI. So your final volume minus your initial volume. So now take that, take your numbers and calculate and see what you have. Now I'm going to do the calculation and then I'm going to tell you the answer, okay? So go ahead and do that real quick. Did you do it? I hope you did. It helps you to practice. I can sit here and talk to you and I can do that, but it helps you to practice. So I want you to try, okay? You're at home, you're learning, there's no one here to judge you. I can't even see you. So if you get it wrong, you get it wrong. Maybe you'll know what you did wrong. So the final volume that you should have gotten is 6.8 milliliters. If you got a negative number, you just you did 28.9 minus 35.7. If you got a negative number, ask yourself, can this have a negative volume? Use some common sense on some of these problems that you're going to have to do. Does this have a negative volume? No, it obviously has a volume because I can feel it, it's in my hand, it has a volume. So it's 6.8 milliliters. Now, from here, you should be able to find your density. So take a moment, see if you can figure out your density. And while you're doing that, while you're taking a moment to figure it out, I'll go ahead and write it for you and then see if you match my answer. Don't forget to show your work. Keep going. You got this. Make sure you're showing your work because you're still going to have to show it, especially in lab reports. All right. So the answer that I got was 5.89 grams per milliliters. And there's my work. So that's what I got for an answer. Remember, irregular objects are going to be milliliters because we're doing it in a graduated cylinder. For regular objects, it's going to be centimeters cubed. There is a difference between those, so be aware of that. So hopefully you got that answer. Don't forget, if you got 5.88, what you did wrong is you just didn't round. It should have been 5.88 and there was like a 7 after, or 5.889. And so that 9 rounds up the 8, okay? So it becomes 5.89. If that's what you did, that's easy peasy. We can correct that, not a problem. The rest of it should be fine. Hopefully you were able to solve those and get the right answers. If you did, great job. If you didn't, that's okay. You'll see me and I'll help you fix where the mistakes are, or you may have already figured it out on your own. So great job. This ends the lecture for both lab equipment, some lab equipment, lab safety, and density. You are going to need to know all this for your lab that is coming up this week, either this week, Friday or Monday, somewhere in there you're going to need to know this information. So good luck and hope you enjoyed the video better than sitting in my class. Maybe.